So, welcome to the first of 4 videos on electrolysis, and this first one covers the very basics of electrolysis, definitions and how electrolysis works. So, what actually is electrolysis? Well, chemists tend to think of electrolysis as the decomposition, which you could think of as a breakdown of a compound, and this decomposition only occurs when electricity is passed through the compound, and this causes the compound to split up. Apologies for the writing, it's the first time I've used a stylus. So these are 5 more terms which you need to know. The electrolyte is the substance which is being electrolysed. Now the electrolyte is usually, or has to be, either a molten or aqueous ionic compound. And the reason for that is that if the ionic compound is solid, the ions can't move. They're locked in a fixed position in the lattice. However, if you heat the ionic compound up so much that it melts, or you dissolve it in water, the ions in the compound can move between the electrodes, and therefore electricity can be conducted through the electrolyte. Now, I've just used the term electrodes, and there are 2 types of electrodes in electrolysis, the anode and the cathode. And as soon as I mention the word anode, in my head I think of this wonderfully upbeat student I taught years ago called Andrew, and he was incredibly cheerful about everything. He was incredibly positive, and believe it or not, that's how I always remember what an anode is. It's the positive electrode. And conversely, cathode, is the negative electrode. The final 2 terms we need to use are oxidation and reduction. And in this part of chemistry, we think of an oxidation reaction as a reaction where electrons, and I'm using that as abbreviation for electrons, are lost from a substance. And if those electrons are lost from a substance, generally something else will pick those electrons up. And when electrons are gained, that is a reduction. Now, you could use the textbook way of remembering this. They tend to use oil rig, which stands for oxidation is loss, reduction is gain. But I prefer Leo Ger. And this was what my chemistry teacher used at school 20 or so years ago, and that stands for loss of electrons is oxidation, gain of electrons is reduction. It doesn't matter which one you use, but I much prefer this one because of the wonderful happy memories that it brings back to me. So, this is a typical experiment you might have seen in a lab. In here we have the substance being electrolysed, so that's the electrolyte. And this is the negative electrode, the cathode, and this is the positive electrode. So again, I'm thinking of Andrew, and that's going to be the anode. Now, these electrodes are usually made of graphite, because graphite is very good, it conducts electricity, but it doesn't react usually with the electrolyte. Now, in this case, you can see that our electrolyte is being heated above a Bunsen burner. And that's because the electrolyte needs to be molten so the ions can flow and help electricity to be conducted through the electrolyte. Now, in this case, we're going to use, or say, our electrolyte is lead bromide. Now, lead bromide initially in this experiment was a solid, but we've heated up and heated up and heated up, and when it becomes a liquid, electricity, assuming the switch up here has been closed, starts to flow between the electrodes. Now, what happens in the electrolyte to help the electricity to flow? Well, electricity is effectively the flow of electrons. And in this electrolyte, our ions help the electrons to move. And in our electrolyte we have positive ions and we have negative ions. The lead ions are positive, metal ions are always positive, or pretty much always positive, and the non-metal ions are negative. So we've got lead ions and bromide ions. And these lead ions, which have the charge 2+, are attracted to the negative electrode. And they move through the electrolyte to the negative electrode, and what makes it negative is that it's covered in electrons. And that lead ion takes 2 electrons off the electrode and forms lead. And so when you look in this crucible, you will see a silvery substance start to appear around it. And that silvery substance, okay, beautifully drawn on with my blue pen, is lead itself. Now while that's going on, the negative bromide ions are moving towards the positive electrode. And when the bromide ions get to the positive electrode, the positive electrode, the anode, rips an electron off it. So the bromide over here turns into a bromine atom, and it releases, oh, I've made a mistake there, so I'll just rub that off. It releases an electron, and this electron is dragged back around the circuit over to this side using the battery or the cell up here. Now, bromine atoms are pretty rare, they're pretty reactive, and so what happens is one bromide ion loses an electron to become a bromine atom, a second bromide ion does the same thing, and these 2 bromine atoms bond together. So you have 2 electrons being dragged round, and you get bromine molecules forming here. Now bromine, okay, is at room temperature a reddy brown liquid. Now we can see that we've got a Bunsen burner down here, and what's happening is that the bromine liquid which forms will evaporate very quickly because it's so hot down there. So you'll get reddy brown fumes coming off at the anode, and those reddy brown fumes are bromine. So it's important that you do this experiment in a fume cupboard, because bromine is a particularly nasty substance. You wouldn't want to be breathing in bromine. So overall you can see that our lead bromide is breaking down to form lead and bromine, and you might be required to write that as an overall equation. And so that overall equation in this case is quite simple. PbBr2 breaks down to form Pb and Br2. Another example could be this. Again, same diagram, and let's take a different electrolyte this time. Again, it needs to be an ionic compound, and in this case let's take sodium chloride, normal or common salt. So in this case we've got sodium ions in there and we've got chloride ions in there, and when it's solid it doesn't conduct, but as soon as the sodium chloride melts, electricity will start to flow. And you might like to think now, actually what products will we start to see forming at the 2 electrodes? Now do remember that this is pure sodium chloride. So have a think about the 2 types of ions in there. Okay, we've got sodium, and sodium's in group 1, so sodium will have a positive charge, only 1+, and chloride, well, chloride's in group 7, so it has a 1- charge. So where are the sodium ions going to go? Well, the sodium ions are going to be attracted to the negative electrode, the cathode. So the sodium ions in the solution there will start to manoeuvre towards that electrode, and they will collect an electron from that electrode. And the sodium ions turn from being ions into sodium. So you will start to see, if you're doing this experiment in the lab, some sodium building up around that electrode. What's happening to the chloride ions? Well, the chloride ions in here are going to be attracted to the positive electrode, the anode, and from all over the electrolyte they're going to be attracted to the anode. And you'll get exactly the same thing happening as with the previous reaction. The chloride will be attracted to the positive electrode. It's going to have its electron ripped off it, so it's going to lose an electron. And chlorine atoms are pretty reactive because they only have 7 electrons in their outer shell, so they're going to pair up with each other. So 2 chloride ions will form a chlorine molecule, and each chloride will release an electron. So if we're going to balance that, we'll have 2 electrons on the right hand side. These equations are known as half equations, and you can see that the sodium is gaining an electron to form a sodium atom, and as it's a gain of an electron, that means that process is a reduction. The chloride ions are having electrons taken off them by the anode, and that electron, or those electrons, are being pumped back around the circuit down here to the negative electrode. And this process here of losing electrons, if we're thinking about the definition I gave you a moment ago, Leo Ger, that will be an oxidation. And that concludes our first video on electrolysis.